This is the story. It was really quite a journey. I'd never built a new house before, or we never built a new house before, and I'm not sure we knew what we were in for when we decided to do it. Um, so anyway, this is going to be the story of that journey. And yeah, Joe was our general contractor, and Ryan was brought on as an energy consultant, and he also was the window installer for our new home. And we've been in our house now since April of 2019, so about a year and a half. So that's what our house looks like. And the point of it, I mean, for me, it really goes back to when I was actually young, that I always, for some reason, I don't know why, I don't actually recall now why I wanted to know about building an energy efficient house in a cold climate. But I remember now that I was actually interested in high school. And my first thing that I got really excited about in recent years was a house that was built in Hudson called the Passiv House in the Woods. It was built by architect, I don't remember who the builder was. I think it was Morrissey, but the architect was Tim Ian. And it struck me as they would never talk about how much it cost. And it did come out later that it was over $1 million. I don't know exactly what the price was. And I thought, I don't know why it has to be such a specialized thing, that it has to be something only well-to-do people could afford. And so part of this was I wanted to set out to show that it could be done. Didn't totally succeed, but we did get a house out of the bargain. So this is the front view of the house looking east. We have a lot that is faces east-west, and that's the back of the house. It's a very simple house. It's just a rectangle, so it's pretty simple to imagine what it looks like all the way around. And then this is the view. This is actually the view I'm actually looking right now except I'm at the dining room table. So from the front of the house looking backwards, and you can see there's a door in the back there. That's the master bedroom. There's a bathroom off to the side there next to the sort of the middle lamp. And then to the left where this view is, there's a couple bedrooms, but they're used for my wife's sewing business. And one of them can be converted into a guest bedroom. The intent there was to have a Murphy bed. We still haven't actually put the Murphy bed together, and with COVID, there's no point anyway. So so that's what it looks like that way. And this is looking the other direction. You can see the sliding door, barn door there that can close off that room. And so that's basically it. So like I talked about before, I've always kind of had an obsession with cold climate energy efficient housing. And so in like the 1980s, I was interested in berm houses. And I think in high school, I actually visited one. I was graduated in 1983. And then, so they were kind of the rage then. And then in the 90s, there was this thing called passive solar, which was, you would have your house oriented to the south to get as much sunlight as possible, and then have thermal mass to soak that up, and it would, keep the house warm in the evening. But there wasn't so much about insulation, like lots of insulation and very well sealed. So in the 2000s, I learned about this in about 2010, but this has been, I guess I should have looked up when Passive House actually started, but it came out of Germany. And I learned about it because, again, this Tim Ian, he had a booth at the Living Green Expo, which was at the fairgrounds. It moved around different places, but I remember he was there when it was at the fairgrounds, and he was showing off a deep energy retrofit, he called it. And so we lived in a house in Roseville. This is our house. And we talked to him about doing that. And when he came back with the price, like over $100,000, I thought, well, that's not worth it. It'd be better just to build a new house. Well, it probably would have been better just to do the retrofit, but in retrospect, but that's how it worked out. So we decided to go and build new. So we sold this house in 2016?
2017.
2017 we sold the house, yeah, May of 2017. Yep. And we set out on our journey. And so this is like an example of, I just found this on the internet, of a deep energy retrofit. All right. So Joe was our general contractor. So I'll let Joe talk about his background.
So I entered into the world of sustainable design back in my undergraduate when I was at Indiana University, and I was exposed by a German instructor that was teaching a class called Ecological Designs, and it was a pan class that covered everything from urban planning to sustainable construction, sustainable farming, local financing systems. So I took that sort of experience and went out to the West Coast and worked for another German, a Swiss German, who owned a environmental building supply company, and that was another sort of nexus point where there were builders and urban planners again, architects, landscape architects, the whole range of back to the landers that fill out the sort of natural building circles out there in Portland. And then I got involved with permaculture and sort of spread between renewable energy, food, and urban development, and really zeroed in after a period of time at the Midwest Renewable Energy Association on renewable energy, and then moved into sustainable design and architecture when I did the MS at the U of M here in Minnesota. And during that process, Doug actually was back in the day when we were doing those renewable energy case studies with architecture. I interviewed Mike LeBeau, and he was on the board of the Passive House US group at the time, and introduced me to the Passive House concept during that phase. And so I ran down to Urbana several times and did the consultant training, and that was probably like a decade ago. And since then, I started my own design build company in 2013, and have done a couple of retrofit projects and then some new construction projects. And then recently, after working with Steve and Angie, connecting with Ryan, I jumped in on one of his projects that was down in Lakeville this last year. And I figure if you're going to study under a master, you get a better opportunity to go further. So Ryan by far has done the most passive house projects in our region. So having him on the team as a consultant for Steve and Angie's project was fabulous. It was great learning, and also just fun to have someone that really knew what they were doing, because the pool of people in the Twin Cities actually building these kind of projects is pretty small. So it was exciting to get to do something of Steve's type of project with, the goals that he's talked about, bringing in more of the affordable housing area, and seeing how we can explore that as far as where you can cost planning, do some smaller scale steps to make it more affordable. So I'll jump in here with Ryan and let Ryan sort of do his introduction next.
Okay, go ahead, Ryan.
Hi. I was the consultant for Steve and Joe on this project, and also did the window install. My background's probably a little less typical, if you will, to be involved in, sort of sustainable housing, the sustainable housing realm, which is, as Joe said, very small. My background was, I originally started studying to be an engineer, and fell back on my sort of lifelong drive to build things. I always enjoyed building things, so worked my way through the trades, and eventually started a business on my own, and took a stab at spec building, but couldn't quite build a cheap enough house to compete in that market, and then went to remodeling. Remodeling was great because I've always been a person who's tried to build things better, and the remodeling clients more prone to being willing to, pay what it costs, or tolerate the slower timelines, or whatever it might take to do it in a more durable fashion, or do it right, as you say, or as they say. Which led me to the first Passive House project, the Interfit home in South Minneapolis, which was quite a trial by fire. We got to learn every possible type of envelope imaginable. We had vacuum panels, spray foam, sheet foam, cellulose dense packing, everything all rolled into one project, and managed to get a old house up to the Passive House standards. So from there, because of that success, I've done Pretty much just passive house or similar projects since then. And also try to help out, do consulting where I can, probably a lot less of that than building, but in this case, it seemed to make sense. So, but passive house has just been a really good fit for me because I enjoy the more technical side of it. I've always loved quality, as Steve Slides say, a little bit obsessed with quality and just can't sort of put something together that I know is going to fall apart. So it just made a good natural fit. And since then, since the first project, I think it's been about maybe 7 full passive house new builds or similar energy performance. And that's been my specialty. So so in this project, I acted as consultant, helped solve problems where needed, and did the window install. That's typically a very tricky and detail-oriented part of the build. But overall, just tried to offer, my experience as a resource to the build team.
One thing, just wonder if you could just answer for the audience, what makes passive house a quality house?
So what drew me to passive house specifically was when I learned about it, I really loved was the fact that everything, like if you do a certified passive house, other projects I refer to are not passive house, but if it's a certified passive house, everything is verified by third parties, and it's an energy standard that is focused primarily on the energy efficiency or consumption of the house over the course of a year. So there's really not a whole lot of gaming that type of system. It's a very performance-oriented standard. So there's also hydrothermal analysis that's required to pass in order to even get certification, and that aspect of it guarantees, probably several lifetimes of durability in the envelope. So, but the principles that are picked up in doing these projects they're just good practice. And since then, I've been applying them to every build, and they just make sense. Build tight, ventilate correctly, avoid thermal bridges, things like that. And whether you're doing a passive house or a near net zero or just a really well built home, those things affect the quality. You have a thermal bridge, you're probably going to end up with some moisture there. So that's going to lead to a problem down the line. So,
cool.
Yeah.
All right. Thank you, Ryan.
Mm-hmm.
All right. So we're going to go over our goals here. So our goals were we wanted to build as cheaply as possible an all electric, net zero, possibly off grid power with battery house. And a heated floor was something that I had really kind of been attracted to for a long time. I remember going in a Frank Lloyd Wright house that was outside of DC that had a heated floor and tiles, and I just loved walking around on that. And ever since then, I've kind of been smitten by that. Also, we wanted to demonstrate that net zero is possible for an average family. As I said, the passive house in the woods was over $1 million. We wanted to build in the city to take advantage of all the city that offers for a price that we could afford. Sidewalks, walkability, public transit. And we wanted good southern exposure for solar panels and for gardening. And we wanted to have a yard that employed some, like Joe talks about, some permaculture principles, where we can grow our own food and we can take care of the water coming off of the building so that it doesn't go into the storm sewers. And so those were some of our goals. And so the first thing, when you're going to build new, you need to find a piece of land because otherwise you have to design to the land. And so I had learned that you could get pretty cheap land in the city if you got it from tax forfeited land, which is Ramsey County has it and also Hennepin County has it, and they have an auction twice a year. And so I remember it was in the spring, and I'd learned about it sometime in the fall, and then I said, I should go see if there are any plots. And we went and looked, and what do you know, the auction was the next day. So Angie and I went out and we just drove around looked at all the plots. We found one over on the east side by Payne Avenue. I was actually on Edgerton, and thought, that looks great. So we went to the auction the next day and we bid on a piece of land. And a number of the properties came up and they were like 6,000, 7,000, 8,000. This one came up for 4,000, and none of the other ones were bid on. But then this one, we had a bidder and we had to go bid all the way to $10,000. We finally put a bid for $10,000 and we got the land. We were so excited. So a couple weeks later, we told our architect at the time, like, can you, here's the land. She goes, what, which lot are you talking about? We're like, what do you mean, which lot? Well, this kind of shows you what happened. The lot was empty and there was a sign on it, but it didn't, because we were in such a hurry and didn't really check into it. Turns out they were only selling half of it. The other half was somebody else's. So the lot we bought was the inner part, not even the corner lot. And we, for a while, we tried to first figure out who owned the other piece of land, and then they wanted to sell it to us for like $18,000 for that half lot. And we just thought, it's just not worth it. So we, it was a contract for deed, and we could just sell it back or just give it back to the county. We didn't put that much up for it. So we moved on. So I looked again, I found another lot. This time it was off West 7th. And this was a crazy, it was just like they had like a for sale sign with a phone number on a piece of plywood tacked to a tree. And I called that number, and people were, I talked to somebody and we were like in contract to buy it. It turns out they were a property company that was over in somewhere out east. And it was in December, and we were working through a lawyer to get to the closing. And the day of the closing, we found out that actually they had sold it. They'd already sold the piece of property, even though we had signed a purchase agreement, which is illegal. But on the other hand, it was not worth it to sue them, because it would have cost us more to sue them and get the land. So I was pretty depressed after these two attempts to get a piece of land. So the land we're on, and the one we finally chose, was one that was actually in that first auction, but they didn't sell. So you could just walk into the county and just pay for it. And so we paid $13,000 for that lot. It actually turns out, I think, it's probably the best of the three we could have picked. It's centrally located. I can just hop on a bus on Dale Street, be down to University in like 5 minutes, and I can catch the train and go to downtown St. Paul or down to Minneapolis. It's got a beautiful park 2 blocks away, Marydale Park. It's got a lake. We walk our dogs around it every day. It's really a nice location. So once we had a lot, we had to think about, okay, we decided to sell our house that we were living in before building. So we would have the money out of our house. We wouldn't have to worry about selling it if the economy changed or whatever. We were in the middle of building. We didn't want to have that stress. So we got the stress instead of like moving around. So the first 4 months after we built it, we lived with different relatives. We were living in Woodbury, in Onamia, Minnesota, in Hallock, Minnesota, till finally we realized, well, we need to be living in the city. So we got an apartment in Minneapolis that was like a sort of a month-to-month rental. And we paid pretty good amount for that. I don't remember, we were paying $18.50 a month, I think. It was a lot, but she accepted dogs. And that was a struggle in itself, because our dogs like to bark at things. And so we had to always try to keep them quiet so we wouldn't disturb our neighbors. And we were very happy to get out of that apartment. Anyway, so that was a thing we had to deal with. And then getting an architect and builder. So I was under the impression that if you wanted to do something that was a high efficiency or passive house style house, you had to get an architect, and they would use Wufi Passiv, which is a simulation tool, to build a house like this. And that's not actually true. That's one of the lessons I've learned. Anyway, so in April 2016, we hired our first architect, and our first design was a 2-story design. It was based on a design that was actually built in Maine. And and we hired a builder after auditioning a couple of builders. That was actually a friend of the architect's, and we were really getting ready to go 2017 in the spring, or in like February. Or what actually happened was that in January, Donald Trump got elected, and the whole country went crazy. Inaugurated, sorry, it was inaugurated, yes, in January. And I said to the builder, can we just like put our plans on pause for, like a month, and just let's see how things go, and then we revisit it. And the builder got spooked and said, I don't want any part of this. So then we lost our builder, and then we had some trust issues with our architect, so we fired our architect. So then we had to get another architect. So we went and got another one. And at that time, we actually talked to Ryan about being our builder, but Ryan had other clients in the hopper that were closer to actually being in the build phase, and so we couldn't get him. And so we then found out about Joe, and we hired Joe as our general contractor. And so that was April of 2017. And during the summer, we spent time doing cost analysis on how, like, one of the main things you have to decide when you do a passive house is what is your wall system going to be like. And so we actually evaluated like 4 different wall systems, did some cost analysis on that, and because of that, we ended up deciding to go with insulated concrete forms. And so we did all that, and then we got to the point of we needed to get plans to get city permits so we could build, and that was taking forever. And our architect was putting in some ridiculous requirements that were going to cost us a lot more money, so we fired architect number 2. And from that point on, that was where it was really helpful to have Ryan involved. Joe and Ryan helped us actually redo the plans a little bit and get everything all the way through. And so then that was March of 2018, and then in the summer of 2018, we redid the plans, and we started in August of 2018, and we finished in April of 2019. Okay, so one of the things about a passive house or net zero house is that it's just really very simple if you understand it, and it's a shame that not more builders really know how to do this, but you're basically building like a thermos. You're building something that is very well insulated and very tight. And because of that, you need to have it mechanically ventilated. And then the other thing you really take advantage of is you want to have a nice southern exposure, that you could have an overhang that in the summer would shade the windows, and in the winter would allow that winter sun in to help heat your home. And it is really wonderful in the winter in this house. So one of the things is we wanted to make wanted to make it affordable. So we did things to make it as simple as possible. We just did a 1-story design. We have no basement. It's a rectangle. We had a detached garage and a screen porch on the back, with the idea that if we couldn't afford it, we would just leave those off. We ended up actually including both of them. The garage, for one thing, was really useful because we could store supplies in the garage. It could be locked while the house was being built, so the garage was built first. And the screen porch was just, it's been one of the things we really enjoyed about the house for sure. So I'm glad we didn't omit actually either of them. So after examining the 4 wall systems, the ICFs were a little more expensive, but they were in the ballpark of all the other ones, which we looked at were SIPs and a double stud wall and something like an I-beam. What is it called?
Like doing a vertical eye joist. Vertical
eye joist, thank you. I couldn't remember the term for it, yeah. So then, of course, we picked a lot. And the one thing is, we spent $15,000 on a lot, where typically in the city, if it's in a more wealthy neighborhood, this is more of a poor neighborhood, it would have cost us over $100,000. So we thought, let's put the money into the house and not into the lot. All right, so this is a sort of an overview of the mechanical systems, and I'm going to let Ryan talk a little bit about the mechanical systems here.
Sure. So for the primary heating system, the house has a central ducted air source heat pump. And what that is basically, it's a heat pump that's packaged in a box that looks pretty much like your typical furnace and AC unit, except the equipment itself is an actual mini split unit, which is just a very efficient type of heat pump system. So it'll operate very cold weather. It cools very well. It's very efficient. So that's a centrally ducted system, which looks pretty typical, except for the fact that there's no gas. And then cooling is also taken care of by that same system. The air exchange or house ventilation, which is bringing in the fresh air for the entire house, is a Zender system. We like those because they're very efficient, very durable, just a problem-free machine on all of our builds. So they're a little more money than other brands, but they are well worth it, in my opinion. And those are fully ducted. I think what's most unique about that in these performance houses is that we duct the entire system separate from the heating system. So it's not tied into a return anywhere. It's a completely separate system. And it allows it to function efficiently, and it does a great job of ventilating, keeping the house nice and fresh and avoiding buildup of humidity while keeping things pretty comfortable. And then the hot water, well, actually, I'm sorry, to go back, what I missed was the heated floor that Steve mentioned was a pretty simple electric, they're called a electric mini boiler. They're not a very big boiler. It's
what size of a cigar box?
It's a small thing on the wall that's the size of like a little bit thicker than a computer laptop, and then that's connected to the tubing in the floor with a pump and heats his floors. That's not necessary with this type of build, but that was something that they chose to have for that extra comfort. Hot water is heated with a Rheem heat pump water heater. Again, going with something simple, efficient, and works really reliably. These are just something you take out of the box, you connect it with electricity and plumb the plumbing, and it's done. So they're a really nice form of efficient hot water production. Washer and dryer. The washer is a high efficiency front loading washer. The dryer is a bit more unique. It's a condensing heat pump dryer, because heat pumps are more efficient, but the condensing side of it is what's most unique, because on a tight home, it makes a lot of sense to avoid having that dryer outlet through your wall, because now you're basically pushing 150 CFM outside of your envelope that you just spent all of that time and effort sealing up, and then something's got to come back in to replace that air. So you get a lot of random leaks, exaggerated and so forth. And so in my experience, it's just worked really nice to avoid that duct altogether, do a condensing dryer, and the heat pump makes them very efficient at the same time. So they've been a really good fit for this type of a build. Stovetop is a induction cooktop, which is an electric cooktop, but they use it's basically an electromagnet that heats up the pan instead of resistance heat. So they're a bit more efficient. Probably the biggest advantage is that they heat up really fast. So they're something that can heat a pan up even faster than a gas range. So that's kind of a nice upgrade, because you're getting something that functions well while you're also increasing your efficiency. And then the hood, you want to use a recirculating vent hood anytime you're building a tight home, because you don't want to create another hole in your envelope. So it makes sense to just recirculate that back into the house. And because it's electric, you don't need a lot of CFM.
And also it brings the air up high in the ceiling, and then there's a vent there that goes back to the air exchanger. So it takes that moist air right out of the house because of where the return is for the air exchanger.
Steve, I don't know if you saw that or not, but someone asked what the type of dryer was, what brand that was.
That was a Whirlpool.
Yeah, Whirlpool. LG had made one for a while, but I believe they don't offer it anymore. So at the moment,
Bosch?
The only one I
Bosch has
know in the U.S. that's a heat pump condensing dryer is the
Okay.
Whirlpool.
Whirlpool. Yeah. Okay, moving
There
on.
are other models that are condensing. They do the same thing. The heat pump condensing are just more efficient. It's kind of like switching from electric resistance heat to a heat pump. You're typically going to cut the electric usage by roughly half. So
Right. Okay, so the next thing was the solar. So when we did the architect number 2 did a Wufi Passiv model, and it indicated we would need 3K of solar. Hey Joe, can you keep track of the chats? So I don't know what somebody else chatted, but you can just look at it. And so we put 3K, or we actually put 4K on the house, but it turns out that's about half of our usage. Actually in the spring we're going to be adding more, and in the summer this summer we got a Chevy Volt, and so we're actually going to be tripling the size of our solar array to handle both the house and now the car. And then the next thing, a big consideration is the windows. So we looked at like 5 different window manufacturers. And the thing about windows in a house like this is that you want to make sure you get a really good seal. And in order to get a good seal, you need something like, you don't want something like a double hung window, because that sash is always going to be wearing as you open or close the windows. Whereas the kind of window we have is it's called a tilt turn window. You can either tilt it in at the top, or you can open it like a door. But in both cases, that seal only just presses against the window frame. So it makes a very good seal, and it also is going to stick around a lot longer than your double hung. So you either want to go with like a tilt turn or with like a casement window. Anything you want to add to that, Ryan?
Yeah, I mean, I think you got the basics. One other thing that we look for in a higher performance window is multiple seals, because no seal is perfect. And so we typically use at least a double seal, if not triple. I believe Steve's are a triple seal. Most of the Euro windows are. And with that style of window, you get 3 continuous seals, all the way around the perimeter. So there's less chance for a start-stop in that seal where you get a gap over time, or even on day one. So you can do the same with a casement-style window as well. So that is also a good option for a high-quality window. You just need a manufacturer that has a frame that can handle a nice, thick thermal glazing unit inside of that frame. That's been one of the biggest hurdles with some of the typical manufacturers, because the frames are so light, they can only handle a glazing unit that's 3/4 to 7/8 inch thick. And with triple pane, that leaves you with these really skinny gaps between the panes of glass, and you don't get much insulation. So you want to have thick glazing. Like in Steve's house, it's about 1 5/8 inches thick from outside to inside of that glass.
Okay, so I talked a little bit about Wufi Passiv, and the attraction I had to it was that you could design and simulate your house before it's built to make trade-offs, but it didn't really work out like that, because it's a little too hard to change the design. It takes so much time to set it up that if you want to switch out, say, what type of wall you want to build or what the geometry of the house is, I don't know. At this point, I don't think it's where it actually should be. This stuff should just be integrated into normal CAD programs.
If I could just add one quick thing, and I think it depends on the person using it too.
Well, that's true, and that
makes
so that was architect number 2, and we're not going to go any more about that. All right. Yeah. So, and the other thing about it is that when you're designing a house, aside from all this stuff about the energy usage, you still got to design all the things that are just in any normal house. And so, in order to keep costs down, we used cabinets from IKEA, which, when people walk into our house, they go, "Oh, where'd you get those cabinets? They look so nice." So I guess it didn't detract from, they don't look cheap, and they've worked reasonably well. For the bathroom shower, we just used a fiberglass insert because we didn't want to be cleaning grout. We did that for many years at our other house. And then we just have a plain concrete floor, which, we might have done it differently. And at some point, I think we may cover it with some tile, but it's still working, and it's working out okay. And then we only have 1,100 square feet, so we did one of the bedrooms, we made a flex room so that my wife could use it for her business. And when we have guests, we could turn it into a bedroom for a short period of time using my Murphy bed. And then we also finished out some of the overhead space. We have a vaulted ceiling, but we have parts that have a drop ceiling, and we use space above there for storage. Okay. The build. Joe, you want to talk a little bit about the soil issues we had?
Well, I think part of the process that didn't happen early on was identifying the soil profile. And so once we found out what was going on below grade, the past life owners of that site had basically dumped garbage soil back in over the top of the past life foundation. So we ended up digging down several stepped footings to get to where we had virgin soil to be able to build on. And by the end of it, we ended up connecting also with whatever past life pipe had gone into the sewer system. So we ended up sending one of those little mechanical robots to go into there to prove that we could still connect to the sewer system. So there were a lot of steps in that part of the process that, normally we go down 42 to 48 inches and put a footing in, and we're ready to go for a slab on grade. And that was not the case here. So we ended up digging down pretty deep. And that added significant cost. And there was a range of solutions after working with a commercial entity that did the first review, and then we came back with Pat Hines later on, and his review was much more favorable because I think he was more involved with residential and less nervous about making recommendations. But at one point we were looking at helical piers, which could have been anywhere from $50,000 to $200,000 for a solution to put a slab on grade 1,000 square foot structure. And so it was pretty counterproductive to even think about finishing the build project at that point. We were pretty discouraged. So when Pat came on board, our review was much more favorable, and he came up with good solutions that we all could work with. And so the excavator, Eric Berg, he's been on pretty much all of my projects, was really fantastic for working through the dig process and dealing with the sewer system. And I think the solution that we ended up coming up with, probably, I think Steve jokes about it, but we're at a stage where we were pretty deep on the north wall. So
yep. So this is what the lot looks like before we started building. This is looking from east to west, and it's looking from west to east. And that's there. You can see the slab for the garage in the background. And so this is the hole we dug, and we're looking east here, and you can see in the foreground is where we had to dig down like 8 feet. That's where there was a house here before that got knocked down by the city, and so, like Joe said, when they filled it, we can't blame it on the homeowners, more on the city. When they refilled it, they didn't compact the soil so it could just be built on. So we pretty much had to dig out. We weren't directly over the footprint of the old house, so this corner was where it overlapped, and so that's where we were digging down 8 feet. Unfortunately, after we dug the hole, I don't know if you guys remember this, in September 2018, there was like 5 inches of rain. We just got torrential rain. And so we had to get a pump to pump out the mud that was in the hole. But thankfully, it didn't delay things too long. Here we are putting the forms in.
So Steve, if I can jump in for a second. So
I was just going to say, Joe, you want to go from here? So
the one of the sets of the strategies that is important with a high performance structure that you're trying to eliminate, like Ryan said, you're trying to eliminate the thermal bridging, and the contact with soil is a significant one. So what we ended up doing below the footings, we did these, I think they were 3 inches in thickness. And we just basically had these manufactured as far as it's a foam coffin really, but the U-shaped space allowed us to fill in with concrete and then buffer up and over the top, and then just break off the edges, and then put foam over the top of it, and then place the insulated concrete forms on top of that slab. And we worked with a colleague of mine that had gone through the grad school program in the MS in sustainable design with me, Lance Fisher, with Cultivate Construction. He helped orchestrate the concrete pours for the footings, the ICF walls, and then helped me with the framing of the trusses as well. But I think what's important there, if you kind of looking off to the left, I think is that Angie dancing in the background there?
No, that's actually our daughter Rosie.
Okay. But on the left side is the entry for the porch. On the middle right is where you'll see the footings that were for the safe room. So we did a room that was for disaster or hurricanes or whatever, Midwest monster we see in the world. Mostly windstorms is what we're looking at. But with the ICF walls, I think it's pretty redundant to have both a safe room and inside. But what's beautiful about it is the barrier of the sound is also there with that concrete wall, and then the insulated concrete forms had an extra layer of foam that goes into the inside the form as well. So you can see.
Yeah, describe this. This is placing the insulated concrete forms. Yeah, you can talk about that.
So essentially, they're Lego blocks that are 4 feet long and about 16 inches tall, and then those foam chunks that are behind me. Essentially, they look like a comb, and they slide down over the plastic ties that hold the two sides of the ICF blocks together. So you're essentially, those little ridges on top are nest into the row below. So essentially, you've got a Lego block that is super lightweight, but you definitely, at the end of the process, put forms up to make sure that the wall stays solid. And then we insert rebar. You can see that bottom right corner, there's a chunk of rebar in there. And we did that every other course, and then filled in at the corners with bent. And then around the perimeter, we used a dimple mat below grade, which is basically, it's just a plastic surface that helps push the moisture off and away from the building. And then also, because it's a thicker plastic, it also, when the backfill is happening, it protects the foam from any excavator contact or anything like that. And then for this brand of insulated concrete form, that 4-inch chunk of foam sits to the exterior side of the concrete, and then they have these little wire ladders that you kind of wiggle in at the top row and a couple courses throughout, and it helps keep the walls straight in the process.
So this was after it was poured, it was backfilled, and we were ready. So we started in the beginning of September, and now it's October 21st, and we have the foundation all done. The garage is built. And you can see also the base of the safe room there. We did two different sets of pours for the walls. We did and actually three. One was the footing, and then we did the stem wall or the frost wall. And then above grade, we did another pour later on. Right.
And that was after we got the window bucks and all the reinforcement on.
Yeah, so just talk about the window bucks a little bit. Like, what's the point of all that?
So we basically we built a plywood structure that had the center section that we could remove and provide structural integrity. Basically, when you're pouring concrete, it's pretty heavy, and so during the pour process, we wanted to make sure that the frame stayed square so that when Ryan came around, he didn't yell at me for having crooked windows to put in. So we basically over-engineered the window bucks to make sure that they stayed solid.
Okay. And so here, this is after the pour of the above ground wall. And then we started doing the trusses. And so now we're November 20th. We're about almost 3 months in, and the roof decking. And then on the inside, okay, so actually, so the slide is wrong. But anyway, so the next thing I want to talk about was that the ceiling. So there's this, well, you can talk about the whatever the barrier. I can't remember.
So it's an intelligent membrane is the jargon.
Very
but essentially say that again, Ray?
It's very smart.
It's a very smart. It's brilliant. But basically, what it allows us to do is to put the membrane across the bottom of the trusses, and they were scissor trusses, so the insulation for the cellulose is blown in above that, and that was about 2 feet at the edges, and probably give or take 3 feet in the center. And so, of course, when the inspector pokes their head in, they see the second row of measurement tapes that stick out, and they're wondering why it's such a narrow number. And you have to sort of go backwards and explain there's almost 3 feet of insulation in the center there. And then what we did below the membrane, it's got the blue lines. If you look around the perimeter and down the center, it's a higher tech tape that, in combination with a schmancy caulk, the goop sticks the edge of the membrane to the ICF, and then we taped over that. So sealing the process between any penetrating pipes. I think we had a couple of vent pipes that came out on the backside in the corner. But we tried to keep everything minimized as far as anything going up through that layer. And then to be able to run any kind of electrical conduit or Romex or any suspend anything, we put the 2x4s across the ceiling. So we dropped the ceiling down, and that made it a simpler step for people to do wiring and hang stuff on. So like above the stove is the recirculating hood, so we hung it off that 2x member as well, and then just fastened the drywall to that. It also added rigidity to the overall truss system, and that made the inspectors happy as well.
Okay, so here we are doing the floor, and you can see this is actually before we put the membrane on the top, and so there, put foam down underneath the slab. So in this case, we have 6 inches of foam underneath the slab. It's a floating slab. And here it is after it's poured. And you can see that's the safe room there. We used a different ICF for the safe room that was not as thick, because of course we don't need to insulate against the outdoors. But it provides us a concrete box in the case of a tornado that we can go in and feel safe in that case, in case the roof came off. Even though the walls might be there, the roof could still come off in a tornado.
And you pop back for a second, Steve. So the tubing sticking out is the end points of the out and back loops for the radiant floor. So you can sort of see that PEX tubing is mounted to the same stuff that we also brought up all the conduit from the exterior down and through the lower wall of the exterior footings, or not the, I'm sorry, they're at the top of the footings through the frost wall.
Yeah. So this is I just got 3 slides here to talk about the windows. So this is what the bucks look like, is one of them. And then here is an installation where it shows how it's being taped and sealed on the inside. Ryan, you want to talk about that a little bit?
Sure. Yeah, so this is a installation of a Euro window. This has been a sort of a typical detail for many of the projects that we've done lately. It can be a varying cost level window, but the process of installing is the same. They're a bit more labor intense than a typical window, but like many things, you get what you pay for in a sense. So the window sets on, I believe did we have a foam block, or was this 2x block underneath, Steve?
That's a good question. We'll never know now.
Yeah, but anyway, there was a block of some sort, whether it was wood or foam. It may have been foam. Yeah. And what we do is try to incorporate a taper to the outside with that piece of foam at the base, set the window on top of that. And then on the outside, the jambs of the window are insulated so that the insulation goes over the frame, which eliminates a lot of thermal bridging on a window install. And then we sort of just cover that with architectural sheet metal that I just have made to size. And we also do a custom pan at the base, which is also tapered out. So you sort of get 2 layers of water protection at the base of the window. And then the sides are all installed over that so that, regardless of what happens, that the water is going to flow outward, which initially in my first projects, I used to worry about this a lot, but now having done this many times and seeing the houses and how they perform, they actually really don't get as wet as you might expect. So,
So
and then lots of tape. I mean, in that first picture, every joint is taped. So we tape inside and outside of every window, fill the gaps with foam. So it's always at least a double seal where that frame meets the wall. And you can see that even at the end of the plywood buck, we had to run a piece of tape across that as well, because plywood tends to have voids and you can get air leaks through that. So it's kind of a tedious process, but it pays off in the air tightness, which makes the house more efficient.
So if you can hang there for a second, Steve. One thing that's noteworthy in this picture, you can also see where I routed out all the walls for the electrical conduit to be run around the perimeter. And that, that's one step that if you have the electricians doing that, you're going to pay a lot of extra. And as far as being the general contractor on the site, it provided me an easy thing to be doing while other people were doing work, and be their sort of monitoring process, but being active. Because there's definitely times when people just, if you're not there, it's not a good plan to have that membrane not being monitored, because that's the easiest thing to catapult disaster, is when someone with a utility knife is loose and accidentally cuts the membrane on the ceiling, or on in other projects when you use it on the walls. So really staying on top of the crews. It's easy to do that when you have something like this where you're sticking around on the site. So we basically got the conduit in and then spray foamed to fill that cavity back in afterwards.
Okay, and so this is when the framing started, and then here, again, talking about what Joe was talking about here, he had to route out where the plumbing went, and also the electrical out of the foam. And then here they're putting the sheetrock up, cabinets, hanging the barn door. Then we had a custom backsplash done by the artist there on the left, Lori Green. She's probably not going to appreciate that picture, but that's what I had. And then this is what the mechanical room looks like. That's the in-floor heat on the left. And then we have two electrical panels. One, the one on the top left there, is meant if we do get a battery, that would be our backup power system, would power the fridge and the outlets and some things.
The boiler for that floor is actually that white box next to the expansion boiler there.
Yep, the boiler. The rest of it is just all plumbing stuff and pressurization. That's the heat pump furnace. Oh yeah, and this is we have exposed ductwork in the main room. So this is the conditioned air ductwork.
So like Ryan said, there were two trunks. One stayed on the south side of the center wall, which was the heat and cooling distribution, and then the north side was the ventilation side.
Right.
And provided just the fresh air.
Yep, just the fresh air. And this is the heat pump. And then here's the water heater and the washer and dryer. And then we did blower door test. You can see before we actually put the walls or the sheetrock up and everything, it was 77 CFM. And then when we were done, it was 49 CFM, which I should have worked this out before, but it's very tight. Probably something like 0.2 or 0.3 ACH, whereas your standard build.
0.2 or lower would be.
What was that?
I mean, my guess would be your 0.2 or maybe lower.
Okay, maybe, yeah, something like that. Whereas your standard build house would be 1 to 3. So very tight compared to a standard build.
You're at least 10 times tighter.
Right. Yeah. And then here they're installing the solar, and then pouring the slab, and then putting the siding on in the middle of winter. So
if we pause for a second there on the siding, one of the other strategies that's just good building practice, if you see those little white pieces of 1x3 sort of sticking out in weird places, we did a rain screen behind the siding, which pushes the siding away from the building and allows drying to happen. But you also have to provide, a bug resistance layer underneath the siding at the bottom edge, and then making sure that you also can allow moisture to drop out of that as well. So it's a common strategy for better built buildings, but
it extends the life of any sort of siding. I mean, aside from maybe steel, but steel is sort of naturally vented on its own. But it's
Yeah.
I mean, from studies that Building Science Corp has done, I think they say that it safely doubles the life of a siding product. So.
Right. And, you know, the
It's a good
challenge
practice.
is working with siding contractors that haven't messed with it. They get a little bristly, but you just got to hold their hand and walk them through it.
Okay, so here is the house done just before the yard is graded, and then this is the after it's graded and sodded, and this is last summer, and then this is was just this fall. So this is after all the plantings have been done. We have our garden on the south side of the house there, and our herb garden up against the house, and then shrubs in front. And over on the other side, you have natives on that northwest corner of the house.
And if we can pause, can you sneak back to that for 2 seconds?
Which one?
One of the things that I think you didn't mention, Steve, was, you know, one of the things you were excited about this site in particular was that tree in the backyard, and the balance between big trees and other structures when you're doing solar or high performance structures, you're trying to do the passive solar heat gain, is that orientation component. And other strategies like the tree that's placed out in the west side, where you're trying to use a lower height tree or landscaping or shade structures to deal with that lower end of the summer, when it's like late into July, into August and September, when you've got that low angle sun coming in those west windows. But I think, you know, it's exciting to have the big tree, but it was great that it wasn't prohibitive to putting the solar up.
Right. So the benefits, you know, of course, living in the house you dreamed of. It's very quiet. It's very comfortable. It has wonderful southern exposure for the winter sun, and the screen porch is also great, especially with that tree in the backyard. Provides great sun even in the morning, or great shade, I should say. And then living in the city is also great. So anyway, and it's one of the things, you know, it's been an obsession for many years, and it's a relief to actually not have to think about this. I can move on with my life. The pitfalls, building a house is exhausting, and then being uprooted for a couple of years was hard. And also, once you actually get into it, it's a one-way trip. And so we actually thought of abandoning it sometime through there and just buying another house, but oh my God, Dobby. But we managed to push all the way through. Lessons learned, you don't need an architect to do a net zero house. The resistive heat we got, I didn't realize, and the electrical contractor didn't say how much energy it would use relative to the heat pump. We still like the in-floor heat, but it is a bit of an energy pig. But it is really nice. And the heat pump, actually, we never had it. We're always talking about you need to have backup resistive heat because they don't work at very low temperatures, but it in the last winter, it worked. There was never a time when it was so cold that it did not keep up. And we could have used more storage room. And it would have been nice to have a service cavity instead of routing out the foam for the electrical and the plumbing. And then doing a plain concrete floor was not perfect, but it does work. And then the curtains are a struggle because they tilt in, so you can't have a normal like a blind or something on it. So we're still working on solutions for that right now. So I just want to cover the team. We have Joe and Ryan, of course, and then Lance Fisher did the concrete. He's with Cultivate Construction. Eric Berg, he's like Berg and Associates, I think. He did the excavation and the grading of the final around the house. Pat Hines, and he saved the project by doing the soil testing. And Dustin Dennison and AEI did the HVAC and solar. AEI, unfortunately, is no longer in business. Niles Construction, the internal framing, sheetrock siding, Focus Electric, master plumber. And then I just want to say, in memoriam, I want to dedicate this presentation for Joe's son, Hunter, who actually is in the picture with Joe at the beginning there, who passed away in the past year. So that's it. Unfortunately, I actually have to go. So I'm just going to check through the chat here. Is the heated floor a resistor source? Yes, it is. Oh, okay, that's been answered. How low can the temp work in? Well, I think, yeah, down to it was like -10 and it was still working. So, yeah, so it was, I think everything's been answered. So thank you, everybody. Like I said, I have to go out to another meeting I got to do. But thanks for joining me, and I hope you all enjoyed it.
Thank you.
Thank you so much.
Hey, thank you, Steve. We really, really appreciate it. I'll be in touch with you in the next day or so. And
Okay, sounds good.
beautiful presentation.
Right.
Really good. Really good.
All right, thank you. Bye, everyone.
Thank you so much.
Yep.
That was amazing.
Thanks for having us on board.
Thanks, Joe and Ryan.
Thanks, Joe. It's good to see
Yeah.
you.
Good to see you guys too.
Thank you.
Yeah, and
nice
anybody
to
would anybody who's able to stick around for a little bit, I think as Victoria mentioned earlier, we'd like to extend the meeting a little bit so that we can have some more questions and answers or conversation with whoever is still here.
Sure. Yeah, I could stick around for a little bit.
Yeah, Ryan, you're still there.
Yep.
It might be nice to put this video on Facebook with MRES if you guys are open to that. Let us know
Yeah,
if that's.
I would be open to it.
I think that's what
The plan.
that would be the plan,
Yeah,
right?
Wonderful.
we definitely would put it up on YouTube, but yeah, Facebook is another option. The one question I wanted to ask you guys when I came over or went over to see it was during that extremely cold weather that was hitting Minnesota at that time. I forget,
Yep.
there was a special name for it. Did that cause?
Yeah, we had the polar vortex.
Yeah, there you go.
Mhm.
Did that cause any additional problems in what you guys are trying to do, or were you already working inside?
No, we were inside at that point, and one of the things we had going was a pair of dehumidifiers. They dump a little bit of heat energy, but we used a little 15-watt heater, and at points the plumbers were actually complaining that it was too warm inside. So they were actually opening the windows at different points.
And I would add too that on any of these high performance homes, what we find is that a lot of the activities are actually easier in the winter because you've got a really tight envelope. It makes it easier to temp heat even if you're not insulated. Your biggest enemy is moisture. And I've been through the ringer on that, and I typically have 2 dehumidifiers running as soon as that thing's closed up and we're heating, because you just never know. And like Joe mentioned earlier, you have to really monitor subcontractors, because if they show up with a big kerosene temp heater, then you're going to have moisture everywhere, not to mention poor air quality. So, but yeah, so the higher performance homes actually work well with winter builds.
I was wondering, when you discovered that you were going to have to dig down, a full 8 feet or more down for that one section of the house, did you ever consider about just putting in a basement room down there or something?
That's the running joke with Steve, is that they had this Roseville house and they were adamant that they did not want to have a basement, even though we all laugh at it now. It's like they could have easily had the basement, but they didn't want. But they were
not expecting to have a basement.
They were not expecting to have one, and they definitely didn't want to have one after we got that far down either. So that's we ended up putting the stem wall down there and step footing all the way to the bottom.
The mechanical, I built a house, and I went after. I could do a video like this or a presentation like this. It's quite a process, but I'm alone. I basically didn't have all of your resources. I went with Wausau Homes in the end, but they locate all of their systems in the center of the house in a basement, and then go up from the center, out. And I didn't want a basement either, cost and all of that. And they thought, well, we could put it in the garage. It's going to cost more. Well, we can, we could do a half basement, a crawl space. And I thought, well, screw that. If you're going to go down and start digging, give me a basement,
Yeah.
But I wondered, where did you put the systems again in the floor plan? Is that room, how big is that room and what does that take up? Is it in the center or off to the side or where? I forgot.
So that was some of the remnant of the initial design of the house, and it was basically the mechanical room became its own entry at the same time. So the east side porch, the screened-in porch, there's an entry that comes in there, so everything gets wedged in there, and it's at that
Kind of like a widened hallway with all the stuff.
Right, right. So there's a mechanical closet that has doors that at least covers over the Mitsubishi, but the plumbing is all exposed. So, you know, when they're in their kitchen and that door is open to the mechanical room, you can kind of see from their bedroom or the kitchen straight into the mechanical room. So I think in other houses, they build a mechanical room. And sometimes, like you said, it's in the basement, but you have to have a space where people can get access to that equipment easily. And inevitably,
to
they
your
leave.
point about the basement, I actually have been in the process of designing a slab on grade home for a couple that a little bit bigger house than Steve and Angela's. And even in a bigger home, one of our biggest struggles in the design or the layout of the house was that mechanical component, because you're right, it does work really nice to have it sitting right in the middle of the basement where you can just run that duct kind of up the center somewhere and get it distributed through the floor or the ceiling. You know, there are solutions to keep it on the same level as everything else, but it ended up
they like to put the bathrooms in straight up. So boy, that hot water's fast, you know, straight up in the center. But in the kitchen, it takes a while to get the, you know, if you know, because it's on the other side of the wall, the hot water takes longer to get there.
And strategically, when you stack the bathrooms, the kitchen, and any other room that's got, you know, running water with the mechanicals, and you can have that one wet wall, then you can have one place where if a leak does happen, it's all going straight downhill, and it also reduces the cost of plumbing. But, you know, inevitably people want a bathroom at the far end, and you try to convert them into keep everything concentrated to a center section, but you can't always pull that off. But, you know, plumbing isn't cheap, and those people will cost money, but so does hot water.
Hey, you guys, the one that you just finished in Lakeville, was that anywhere similar to this, or?
It's
performance.
Yeah, similar performance. It's that house is a bit of a monster. It's not small. That house is 5,300 finished square feet. There's 6 bathrooms and 2 laundries, and
Whoa!
It's a gorgeous home. I mean, they're on a beautiful site out in the country. They have 80 acres. I mean, they
got a handful of kids too, so they've got a lot more people that they're populating.
Yeah, they have 4 kids. Todd, the owner, is a avid hobby farmer. He's got chickens and turkeys and plans to get cattle next year, and so it provided us a lot of cheap entertainment. And but yeah, it's a very different house, but a lot of the same concepts are there. Like that mini split system that's heating Steve's house. You know, they sell them in various sizes or whatever. That Steve's is a 2-ton. I think if they made a smaller one, he could have gotten away with a smaller one, but that's just the smallest size they had. This other house that I'm referring to, you know, being a bigger house, we're using a 3-ton. So, I mean, it's still like if we did a normal code built house, the air conditioning would have been a little bit bigger than that, just to cool that home. But, you know, as the heating and cooling system, we have to upsize those a bit for the heat pump, but the house's efficiency is high enough that it really doesn't take much. So, but all the same concepts, everything, the same concepts on, you know, many previous builds that we've done. You know, try to maximize solar gains within reason, and, you know, nice, thick, very well insulated walls, airtight. And,
I might have missed it, but now I don't know if you guys will be involved with this extra solar he's going to put on, but what did he say? Will the new solar he's going to put on, will that take care of 80% or 100%?
I think he's throwing on about 8 kW, wasn't he saying that, Ryan?
Yeah, he's actually expecting to be more than what his load is. He's trying to
powering the car as
yeah, he wants to upsize it for car charging. So I believe he's been running the floor heat a little bit more just to allow for a larger system, which he's going to use. I mean, he wants to be able to use it for car charging. So
Yeah, that's a good way to go.
I have another question. Have you guys ever, as a team or whatever, ever done multifamily retrofits? We're working with Dale Howie, who's into that. You maybe know Dale. And I was just wondering, are a lot of the, if your process you described here doesn't apply to multifamily as well?
So the bigger buildings, it's easier to do passive house when you get to a certain volume, just because there's so much surface area and volume to that. But when they're, between 2 to 10 units, it's more like a single family residential strategy. Like the square footage, Ryan was talking about, the last one was 6,000 square feet. And some of those multifamily buildings, when you get to 10,000 to 12,000 square feet, you're still dealing with the same challenges that you do even at the size of Steve's place. So to get that high performance in, it's much more detail, attention on the smaller scale projects, because you don't have the discount on the volume.
Okay, so
You can explain that differently, Brian.
well, I was going to say that we haven't been involved with multifamily retrofits. We've looked at some new build multifamily, and a lot of those, the tricky part was that you have this new build, but then you sort of start stacking on all of these other sort of goals, and before you know it, you're trying to build an affordable net zero passive house and missing middle all the same time, and it's just, you can't throw that together in 2 weeks like the requirements are, so it doesn't happen. But we've looked at it, and I hopefully in the near future it would be nice to see some of that go.
Hey,
Mark,
Mark, when do you want to start the board meeting? Are you?
Oh, yeah. Sorry. We've been running over your board meeting.
let the
I'd say just take another 5 minutes and then come on over. Actually, Catherine's on the WebEx meeting, so I got the WebEx and I'm on the Zoom too.
Okay. All right.
So 5 more minutes.
Okay.
I just had a quick question. Thank you. With regard to your net zero home, how did the energy cost compare to a home similar size that's not a net zero construction? Like percentage wise, is it half the cost in energy? Is it a quarter of the cost in energy with your design?
So the construction cost usually goes up about between 15 and 20%, just on the increase in quality windows, quality doors, and insulation package. But on the energy performance side, you were going to say, Ryan?
Well, I was going to say, if you're truly net zero, your energy becomes zero. So I mean, you're 100% less at that.
Your energy cost becomes zero after the cost of construction.
Yeah, because these are all electric net zero homes. And the nice thing about being all electric is you can decide where your electricity comes from, what the source is. But by being net zero, you're using one energy medium, so you can be legitimately net zero. So, I mean, if you're net zero, that means if you got a battery to sort of bridge the cloudy days, you're going to be just fine if you're disconnected.
Got it. And this is connected to the grid, yeah?
Yes, yeah, everything in the metro will be. Yeah.
Well, and one thing that, and maybe Ryan, you and I can go back and forth on this part, but in terms of the energy model that's used for passive house projects, the energy model actually tries to account for the type of power plant that might be adjacent to where you're getting your power from. So there's source energy is one of the wonky super jargon detail things that gets into the energy model as well when you're really pushing for the net zero kind of projects, because the type of power that's coming at that building is also having an impact on the overall,
Yeah, I believe
outside of just energy itself, you're looking at the global issue as well.
Yeah, that would be if you do the Passive House Plus certification, because Passive House tends to really get into the weeds and analyze every sort of aspect of energy use. And so if you do a passive house plus home, you're not only generating enough electricity on your site, but you're also compensating for those electricity and grid losses in addition to that. So, you know, like if a person did a passive house plus certified home, then they're actually going to see, they're going to be getting paid by the utility for that house.
Right. So they're trying to address line loss and all the stuff.
Yeah. Yeah, so they get, and then they look at what are the typical types of energy production in that area.
Difficult to convert old house?
Pardon me?
I think the question was, is it difficult to convert an old house? And that, I mean, ultimately in any of these projects, the simpler the geometry, the easier the solutions become. The more complex that building with dormers and bump outs and hips and angles and messes, that it's just so much more difficult to, you know, get bulk water off of a curvy building or a building with lots of stuff on it. You try to add in, 4 to 8 inches of extra insulation on the perimeter of that, and it just makes it more complex. So that the more the geometry is simple, the easier our job is.
Joe, you guys have, or you have done some refits, right, on some units?
Yeah, Ryan did the original, the most popular one for the deep energy retrofit that made Passive House. I did a retrofit down outside of Northfield where we started with a phased retrofit.
That's the one I was thinking of. Yep. Well, hey, you guys, I just want to thank you so much. We better get moving on. Really appreciate your time and hanging with us extra long. And
no problem.
We'll hopefully be talking to you more in the future, both of you.
Awesome. Thank you very much.
Thank you.
Thank you. This was amazing.